David Conroy. Dr. David Conroy is with us. Thank you so much for joining us today, David.
It's my pleasure.
We've worked with David for a long time at Fitabase, and he's, in my opinion, one of the easiest people to work with because he always has a vision for things, and it's always really clear. But David is a professor of kinesiology and human development and family studies at Penn State, and he runs the motivation lab there. And that lab is dedicated to developing evidence-based approaches to making behavior change enjoyable and efficient, which you will see some of that enjoyable efficiency later on in this presentation. David and his team have been experimenting with wearables for a really long time and have been doing some of this cutting edge work that we're going to show you, and they're always coming up with new stuff. So I'm really excited to hear about recent work, including Sip It. If you came to us through that blog post, we're going to walk through just some highlights there. But we're also going to talk about wearables in general and just some of his opinions on do's and don'ts and challenges and benefits and that kind of thing. So David, did you want to say anything else about yourself or your work or your team?
Well, yeah, it is a team effort, of course, and there are a lot of people have been in the trenches here. You guys have been great partners. My own lab, I have great students, Ashley West, Taylor Teresi, and a superb lab manager, Deb Reese, who all make things happen internally for us, along with our army of undergraduate research assistants. But then outside of our local lab, we've got some great collaborators. Nicole Streeper is out in Hershey. She's a urologist, a clinician scientist, and she's been really fun to work with on our fluid intake intervention. Edison Tomas down at University of Texas, Austin is a computer scientist who's been great to work with in that space. Constantino Lagoya is an electrical engineer who's been just a fantastic collaborator. He and his students on some of our person-specific interventions, the personalized interventions that we're trying to develop, and working with you guys to get the Fitbit data from. So it takes a village, of course, and thanks for giving me a chance to highlight everybody, or some of the people who are contributing to that.
Of course. So as you're saying, this is a team effort. Can you tell us a little bit about the work that team does at the Motivation Lab?
Yeah, so you mentioned earlier that we try to make behavioral interventions to help make behavior change easier, more efficient, more enjoyable. And that's really the mission that drives us. You know, when we got technology, a lot of times people jumped in and said, oh, we can use this to get people to do more and to engage more in their behavior change. And there was a study that came out, it was about 4 or 5 years now, and they looked at how well people do at tracking their diet using apps. And it was with the MyFitnessPal app. And it showed that, you know, at first people are really curious. They're really good about putting in that work to log their foods and whatnot. But very quickly you find that people stop doing that. And that kind of mirrors what we found with, you know, people who we've asked with paper and pencil approaches to stop or to chart what they're doing and self-monitor or self-track. So it turns out technology is not a silver bullet. And the question is, how can you use technology wisely to help people with their behavior change goals? And from my little corner of the universe, I make a couple of assumptions that people do things that are easy because we're designed or we've evolved to conserve energy. So we're not going to do things that we don't have to, that don't provide a reward. And the rewards that we respond to most often are the intrinsic ones, pleasure. So it has to be fun, it has to be enjoyable, it has to make us feel good. And if we can make behavior change interventions that satisfy those two conditions, they don't require a lot of work from the user, and they make the behavior change fun, enjoyable, rewarding in some way, we have a much better chance of having that behavior change stick and last. So that's what we've set out to do. We use a variety of different approaches. Some require very light touches with users where we really don't do anything at all. It's a very passive intervention. Other forms of intervention we use are a little more intensive, and we need people to work with us a bit, but I think still on the lighter end of the full continuum. more and more, our approaches are shifting away from having people manage and regulate and expend effort to control their behavior, and shifting toward an approach that involves learning and drawing on learning theories and trying to help condition people to use the behaviors that they want to use more. And you might recognize that more as in terms of talking about habit formation or conditioning automatic evaluations of activity. But we think in my group that if you help people to learn the behavior better, then they won't have to work as hard to do it. And we think that's going to be a key to being more successful. So that's a little bit about our approach and how we take on these problems. We've tried to apply that with a number of different health behaviors. We've spent most of our time recently on physical activity, but we've also invested a fair amount of time trying to understand sedentary behavior and fluid intake most recently. So we're broadening our focus a little bit, but trying to stay true to those principles of making the behavior change enjoyable and efficient for people.
Yeah. You mentioned physical activity and sedentary behavior. I want to just touch on that quickly before we go into the hydration and the fluid intake, because we will get into that in a little bit more detail. But can you speak on some of the ways in which you're using wearables for the PA and the sedentary behavior?
Absolutely. Yeah, so depending on what we want to measure, we use different wearables. One of the first things we have to decide in our studies is, do we want to use a research grade device or a consumer device? And initially we would only use research grade devices, actigraphs or active pals. And more recently, we've shifted to using a lot of consumer devices from the Fitbit family mostly. And there are a number of reasons for that. We can talk about those as we get a little further into the conversation. But once we've made that decision for a particular study, we got to think, well, what's the right wear site for this device? Some of them we have choices, and sometimes this figures into our decision about whether to go research or consumer. For our use of the Fitbit devices that are worn on the wrist, we're typically doing measuring activity in terms of physical activity rather than sedentary behavior. And we've also adapted to measuring drinking gestures at the wrist. So this was one of the studies that we worked on with Edison's group down in Texas. And we brought people into the lab. We had them being video recorded from both angles after they gave consent, of course, and ran them through a bunch of different tasks where they could try to confuse a classifier for behavior. Then there was a really painstaking process of labeling these videos, and it was every activity that we could think of, we tried to label. And we broke the drinking gesture into pieces and labeled, when somebody reaches out to grasp the drink, when they lift the drink, when they tilt it back, when they return it, and when they release the glass or whatever container they were using. So then Edison's team applied their analytic tools to try to classify these drinking gestures amidst all the other confusing activities we had people do. The activities themselves weren't confusing, but they were selected to try to confuse the classifier. So we had people brushing their hair and brushing their teeth and eating a meal, eating popcorn, typing, writing on a whiteboard, folding laundry, putting on a jacket, taking off a jacket. So, we tried to do as many different things with the hand and arm as we could to create confusion. And he was able to get a pretty accurate classification on average. I think it was over 90% accurate in detecting those drinking gestures. So the next step in that process then, of course, was when we connected with your team, because it was right around the time, I think, when the Fitbit SDK for the watch came out, that gave us access to the raw accelerometer signals. This was a huge barrier for doing work. There's another collaboration I work with, MD2K Center for Excellence in Memphis, and they were developing custom devices with Emory Ayrton's guidance at Ohio State. But in the consumer space, there hadn't been the ability to get that raw accelerometer or gyroscope signal from people. And when Fitbit made that available, it was time to reach out to Aaron and you and everyone at Fitbase and say, is there a way we could work with this? Could we turn our drinking detection study into an algorithm to detect these drinking gestures in real time? And this was not something that your team had done before, as I understood it. It was pretty much new ground for all of us. And it was fantastic because in a very short period of time, on a very repurposed budget, because we didn't even know we could do this, we were able to come up with something. I don't think it was the final version of what it will be ultimately. I think this is going to continue to evolve. I hope it does. I'm looking forward to doing more of this work. Yeah. But we were able to get a real-time gesture detector for drinking gestures that we could implement as a part of this broader fluid intake intervention. And the advantage was that now we didn't need to rely solely on people's self-reporting when they drank. We could also catch those gestures and offload some of the effort that they required. So we fulfilled our mission of trying to make a more effortless tracking system to help detect the drinking gestures.
Yeah. So let's get into that in some detail then. I have some slides that I want to walk through. I do quickly want to touch on a point that you brought up, which is that this is not really something that had been done. And I know Aaron wanted to kind of speak on some of the technical work that we did, and also just what this meant for wearables in general. So Aaron, while I'm pulling this up, do you want to just give a quick?
Sure. Yes. So I think the other piece of that, is that while you were having that conversation, David, at in your lab, we had really, I think, gotten to a good spot in just so the stars aligned. Our development timeline had a spot where we had really dedicated some time to wanting to understand what we could do, because in the past, for the last 7 years prior to that, there had always been this very rigid divide of, well, no, you're going to use consumer wearable, and those algorithms are baked into the firmware, and there is no sort of raw, 30 hertz, 100 hertz, whatever accelerometer data that we have access to. So, you're kind of on one side of the fence or the other. And when the Fitbit SDK rolled out and we sort of combed through it, very, very early on, we were like, whoa, what is this? We actually can write the code. We can then deploy it onto the wrist. We can have it observe that data in real time and then run it through an algorithm of any, custom creation. And when your group approached us, it just sort of, I think, really aligned to what we were hoping to try to be able to do. And I think for everybody on the call, there's so many questions that I think people will have, and I hope we have enough time to get to them. But this is one of those examples where the sort of needs on both sides of the private company that we're working with and the research team really aligned well, because we didn't have an algorithms person. When Edison was like, well, we can, sort of port this to JavaScript algorithms for you to work, and then we can bring that into the code we were writing. It was worth the experience for us in a way that we typically don't have the resources to do. But I always encourage people to at least, get in touch with a company, if it's us or anybody else, who they think may have, some aligned incentives or some aligned needs, that there could be this really great symbiotic partnership for learning. Because in this case, we're really excited to work on it, but it also really did help us understand. And, it's very exciting because you do certainly know of algorithms that, took raw accelerometer data and retrospectively, found, something that they could measure within them. It could be anything, right? It could be sort of activity levels from people, in wheelchairs, the novel algorithm that did that, or various different ways in which you could classify energy expenditure. But to do it in real time, where the algorithm's actually then sending data into the cloud and then influencing the participant experience, that's very exciting. We haven't really ever seen that done, especially with, an off-the-shelf device, as you said, with not a lot of budget, and just be able to do that and create sort of this unified experience. And so I wanted to point out one that is very interesting and novel, and sort of a new possibility with not just Fitbit devices, but I think specifically Fitbit devices, because they do run efficiently, sort of custom code, but with sort of this very new realm of devices that give us access to raw accelerometer with some limitations, but with quite a bit of potential.
Yeah. And it was really a differentiator for Fitbit to make that available, because we'd been working with another device manufacturer to do the lab study, and we found it maybe one of the biggest efforts we made, aside from labeling the video, was just getting the accelerometer data off the device. It is so much data when you're sampling at 30 hertz and you have a hour and a half, 2 hour long session, that just getting that transmitted after the fact
Mm-hmm.
was a big lift. And there were, if the signal broke down, because it was all done through Bluetooth,
Mm-hmm.
there was a lot of packet loss. So we ended up having to work really hard to just get the data off the device. So when we saw what you could do in terms of processing the data in real time, so we don't need to offload all of the raw data, that was really, really encouraging. And the participants, I don't know if they fully understood what went into the, I know they didn't, because who would? There was a real elegance to how it was all built. The only cost we had was that we drained the batteries in a day, because there was so much data being processed and transferred. But aside from the power savings issues, it was working really nicely for us in the field, I thought.
Yeah. And actually, you just sort of answered one of the questions that got typed in, was about sort of raw access to accelerometer, and it's still a challenge, right? Because you're still working with a $130 device, let's say, and you're trying to get massive amounts of data processed in real time, on the limited computational powers of a computer that's sitting right here on your wrist.
Mm-hmm.
And so we ended up trading off battery life. We would sort of make the device basically able to handle a day and not the 6 days that it could normally do. And then we also, I think it's really important to, approach these kind of partnerships with the open mind that there are going to be other trade-offs that technologically are just going to have to happen. So the question had to do with just, can we get raw accelerometer off the device? You can. The problem is moving it, because we just don't have the bandwidth through Bluetooth channels to do it. And at some point, the memory capacity of the device did, so it's not going to be a complete data storage like you would with a accelerometer device. Its sole purpose is just to put raw accelerometer data into a memory bank to be later offloaded, right? The trade-off that you all decided to make was, we're going to look for this classifier in real time with an algorithm we trust, and send the results of that to ourselves to do some interesting work. And I think that'll become more apparent if we get out of your way and let you show us more of what you had designed there.
Yeah, so I can pull up, I have some slides here. David was kind enough to send us a presentation that he did. So we're just going to go through some of the highlights. I'm going to share, I will share that with you now. I think, okay, let's do, oh geez, slideshow, okay. So I have, why is my screen sharing paused? Okay, there we go. All right, so I just pulled this up because I thought it was so interesting. This was in our blog post. It's the analysis that was done for the drinking motion that you guys were putting together with Edison down at UT. And I just think this is so interesting because it's incredibly complex, and it's what we were able to work with while we were putting together the ultimate product for you guys. But I just wanted to put that up because I kind of love it. but as you said, that ended up being 90% accurate for drinking, detecting drinking gestures. Just so it's clear to everyone, the biggest thing that David's team was trying to get at was making sure that people who had kidney stones were staying hydrated. Is that about the summation of that?
Yeah, so we were developing a just-in-time intervention that would be able to send messages when participants needed them. So we had to build a couple of components to make that happen. And actually, the next slide, Haley, is the one that shows those components. So on the
This, not the other one. Okay.
Yeah, that's the one right there.
Yep.
And if you want to actually blow that up, you can click Swap Displays at the top because we're seeing your slide view or presenter view right now.
Sorry.
No, that's okay. Let me keep talking while you're looking at that. So,
I see what you're seeing. Okay.
Our intervention was just a notification. It was a simple reminder to drink. And you can outthink yourself really quickly, we realized, with how to get people to drink. So we just thought, these are patients who've had a very painful medical condition. They are pretty motivated to prevent that from happening again. It's tough to remember to drink. Thirst isn't enough given the volume they need to drink. So we thought, a simple reminder is probably all they need if they've lost track of time or they've forgotten that they want to drink. So the notification system itself was very simple. It was a message that showed up on the phone and watch. Behind that, though, we had to know when to send that notification. And this is where the decision gets made. So we had a rule that we developed in-house, and we did a lot of interviews with patients ahead of time. We've published some papers in urology journals with those results. But we tried to get a sense of what's the right rule to construct for drinking. And Dr. Streeper, our collaborator, who's a urologist, she had weighed in on that as well based on her experience with the patients. But basically, every 30 minutes, we wanted the system to look at recent drinking behavior and see if there was evidence that people had been drinking. And if not, send them the reminder. So the default was that they got the reminder. But if we did have some drinking events detected and they were sufficient, we'd set some rules for ourselves, we would cancel the reminder. And this was what I thought was nice about this, because I think a lot of us experience this problem with notification fatigue or alert fatigue, where just in the course of this hour, I'm dreading opening my phone and seeing the list of things that are waiting for my attention on that front screen before I ever even get in. But what we're trying to do is we're trying to eliminate that. We don't want to send people reminders. So if people have made a plan, set a goal for how much they want to drink, made a plan for when they're going to drink, they know they're supposed to drink, and they do that, then we leave them alone and we avoid that alert fatigue. And our sense is this is a form of negative reinforcement, and reinforcement is something we see featured in learning theories very prominently. It's part of operant conditioning and classical conditioning. And here we're trying to condition people to drink regularly. So in this case, the decision was every 30 minutes we check. And if you're drinking every 30 minutes sufficiently, we would cancel the notification. And by removing this disruptive notification, and we make a little bit of an assumption that it's disruptive. I don't think it's too wild an assumption, but by removing that, we think we reinforce the drinking behavior. So we had our rule in place then, but we still needed that system for detecting the drinking behavior. And if you can go back to the previous slide, this is where we tried to create what was called a semi-automated tracking system. And this is something that Edison and In-Kyung Cho and a group of colleagues in the HCI world have written about, where you can oftentimes improve self-tracking by bringing in multiple data sources. Very often a single data source isn't perfect. And with drinking is the perfect example of a behavior that can't be tracked with a single data source. So I could use an app, but we know from a long, many years of experience in the dietary research domain, that people won't record everything that they eat. They forget to record things, they get busy, they get distracted, but they don't want to always record in an app. We integrated a connected water bottle in this study based on patient feedback. And the beauty of these water bottles is they're totally effortless for recording. You just drink from them and it records automatically. But the problem is it only records the drinks from that container. So unless you're going to pour your coffee into the water bottle in the morning or your gin and tonic into the water bottle at the end of the day, you're not going to get all of the drinks people are taking in. So we then add the drinking gestures with the inertial signals off the watch. Again, automated, it's almost effortless. It's a beautifully elegant solution until you sit there one day and you have this dawning realization that, well, that's probably not enough either, because somebody could go to a water fountain and drink, or somebody could be holding up a cup with a straw and, you know, they're not having that full gesture that we train the algorithm to detect. So no single method will be good enough to track all of the variety of ways people consume fluids, let alone the fact that a lot of fluids are in foods anyways. So we needed to combine these methods and basically cast a much wider net around how we'll detect these drinking events. So our decision rule incorporates input from all three of those inputs: the manual input from the app, the automated input from the water bottle, and the automated event detections from the inertial sensors in the watch. They feed that information into our server where the decision rule gets applied, and we push out to the phone and watch whether or not to cancel the notification. So that was the gist of the SIPIT system. We called it SIPIT, I think for obvious reasons. We were trying to be a little cute. But it's a very simple intervention in terms of the participant's experience. But there's actually quite a bit of machinery behind the scenes. So just because it's effortless for them doesn't mean that a lot of effort wasn't put into creating this intervention system. We've done something I think that's very technologically sophisticated, but we've made it look very easy for users to incorporate. And people have pushed back and said, you know, what about the low-tech movement? This really isn't a minimalist intervention, but it is a minimalist user experience. You know, you just get a reminder to drink if you haven't been drinking. Our pitch is that with this patient population, they're going to carry a water bottle anyways, or they should. They're oftentimes wearing a watch anyways for other reasons. They're carrying a phone that they could put a mobile app on for other reasons. So we're not asking them to do many things that they wouldn't already do. We're just trying to support them with a goal they have. So I do think that even though we have a few devices that need to be used to implement this system, it is a very minimal demand on the user, and it can be done fairly easily for a patient with kidney stones.
Yeah. And can you just briefly tell us how that worked out? I think I have a quick graph
that
I can pull out just in case people are curious.
Yeah, so this is a graph of performance habits. So this is the habit strength people reported for, basically it's how automatically they found themselves drinking. Mm-hmm. And we found that after just 1 month of using the system, it's a single group pre-post design, so we don't have a comparator here, but we found a promising sign of an increase in habit strength for fluid intake, meaning that people were drinking more automatically, or said they were. In the course of the 3-month trial with 30 patients, we were pretty encouraged by that. We're trying to get funding now to do the RCT to compare SIPIT against treatment as usual, which is getting a little education in the doctor's office. In that study, we're going to move on to some of the surrogate outcomes that urologists are interested in. So people will be doing 24-hour urine collections. We're actually trying to launch some pilot work in the next few months once we're allowed to get back in the lab and have face-to-face contact with people again. But one of the things that we need to do, I think, is understand how does this actually change behavior. It's one thing to say that, for people to say, yes, I feel like it is easier. I am drinking more automatically. I'm not having to think as much about it. But I really do want to know, does this help clinically? Are we getting larger urine volumes from patients? And that's the essence of the clinical prevention guidelines, is you need to produce 2 to 2.5 liters of urine daily, which is a lot. So we're hoping to get those data next. We're tweaking the decision rule a little bit. Patients told us that every 30 minutes was a bit much. There was some fatigue that came in from that. So we're going to probably space it out to about an hour. They told us 45, 50 minutes would be good. We're going to give them a little more time. We'd shown different types of images in the reminders, some that reminded them of pain, some that were a little more positive, looking at the joy of drinking. They just like the joy of drinking photos, so we'll stick with those for our reminders. The power issues on the watch, when we are able to invest a little more in the system, I'd like to see if we can do some more optimization work. A day may be all we get, and a day is actually fine. You can recharge the watch at night and it works out really well. There were some syncing challenges along the way that we just would be in touch with our participants about that. But I think that's just we had a very much what I'd consider an MVP, minimally viable prototype for this intervention that we were testing. And I think we'll be smoothing some of those rough edges out with time. The other thing participants told us, though, is they'd like to try this on other devices. So I know Fitabase has started to build in functions to work with other consumer devices, and where there is accelerometer data available, we'd love to be able to create apps for those devices so that we can use them. Some people don't want to have to wear 2 watches. If they have their Apple Watch that they love wearing, they don't want to switch over and lose that and the different features it has that they have come to rely on. So, we're going to keep working on this. I think that, every intervention is a continuous quality improvement process. We're not done. We've really just begun developing this, but we got a promising signal with that result on habit strength. We got great user feedback. People really liked the system. They gave us some suggestions on how to improve it. We had great retention. So we're really optimistic that this could be something that has legs to it. And the big question, of course, is, does it move the needle on some of those clinical outcomes, which have historically proven very tough to move the needle on? It's very hard to get people to drink even after having a really painful kidney stone. More than 50% of people lapse and don't meet the guidelines afterwards. So we think we have an opportunity to make people's lives better with this tool. Oh, you're muted, Haley.
Sorry, I had some background noise happening. I had to mute myself. So I want to make sure that we have time for questions. We don't have any at the moment through the Q&A system. So I just want to make sure that everybody who's on right now knows that if you want to pose a question, feel free to send it through the Q&A feature. While we're waiting for that, if you guys have any, I'll just pop those into our conversation. But while we're waiting for questions, David, you mentioned some challenges already, specifically for SIPIT, but when you're looking at wearables and trying to figure out new and enjoyable and efficient ways to use them at the Motivation Lab, can you speak a little bit on what are the biggest challenges you have, as well as the biggest benefits to tackling those?
Sure. I think one of the things that we found really nice about using consumer wearables is they're novel and engaging for a lot of our participants. While some have experience with those devices, everybody seems to love gadgets, and being able to offer a gadget as part of the compensation for being in a study is an attractor for people. Some of the challenges, though, are that we don't control everything about that device. These are black box devices, and when changes are made, they may not always be documented or pushed out to us. So we have to be very attentive and alert to keep an eye on where changes are coming from. Likewise, this is a consumer device, so there's a package that it comes in, and we can't turn off features, for example, in the Fitbit app. As much as we would like to be able to control the amount of feedback people get, that is challenging to do. You just can't do that. So, it's just part of working in this space. If you're going to work with consumer devices, there are trade-offs. The nice thing is that they make your tools, if they're effective in your studies, they make them much more scalable after the fact. And we're trying to design for that from the outset. You know, one of the other studies that we work on with your team at Fitabase is our AIM project. And we're trying to develop personalized or person-specific decision rules for sending messages about physical activity motivation. So we have move more messages, sit less messages, and then a group of comparator messages, which are kind of inspirational quotes that we pull together. And in that study, we're getting minute level activity data from your servers after authenticating our users at the beginning of the study. And we've been able to take advantage of the heart rate monitor to be able to separate out minutes with valid zeros from invalid zeros due to non-wear. But one of the challenges we're having in that study, it's not really a challenge, but it's like drinking from a fire hose with the data that's coming in, because it's a 6-month protocol with minute level physical activity data coming in. And we don't have, you know, any extra processing on the devices. So, you know, people are wearing them pretty continuously, except for the charging times. And it is a lot of data that comes through, but we've really found the addition of the heart rate monitor and that heart rate data to be helpful for us for screening things out. But then, you know, like I said, we're having to keep a very close eye on every update to the Fitbit app, make sure we're understanding what's changing. And, you know, that's just one of the challenges of working in this space.
Yeah. Well, this has all been...
I have a question, actually.
Yeah.
Nobody's taking the opportunity yet, but you all can hop on the Q&A if you want. So, you know, one of the things I thought was really interesting when you all were talking about this design, and I think, you know, we did a presentation just this week on some new tools called Fitabase Engage around pushing things to the wrist and interactions on the wrist. Yeah. And I think there's there's probably a tendency in all circles, not just research, when looking at digital tools and technologies, to just continue to be very additive. And you hinted on it, you know, sort of to the point where people have, you know, fatigue. At the same time, I think that we've been hearing quite a bit of enthusiasm for what you can do on the wrist, specifically because, just as you said before, you know, there's a lot going on the phone these days, and there's a lot of competition there. And so it's almost like we're superseding it with some things you could do here. In your case, you guys decided, you know, all the hard work that we did coding this feature and all the tools, everything does what it's supposed to, you know, everybody's, you know, triggering the algorithm and silencing the back end, and nothing, you know, participants are getting nothing. You sort of built a reverse sort of a quieting tool that did, you know, best case scenario, just does nothing, right? I guess, how do you all sit down and think about the participant burden, ways in which, you know, maybe any thoughts on how notifications in the different locations maybe could be more or less palatable for participants?
Yeah, well, we have thought a bit about this, and we would like to move more to the wrist, frankly, because people don't always have their phones on them. And in the AIM study, we're tracking very carefully the timing of people's message acknowledgements. And while, you know, 80% are within 30 minutes, and in previous studies with text messages, we found that most people, when incentivized to respond quickly, do, it still is a failure point. And I think our goal is to minimize those failure points. So getting the information to the person on the wrist is much more likely to be successful, we think. One of the other things that the wrist has opened up for us too, though, is not having to go up to the cloud to get some of the activity data. So there's this challenge of syncing, and even though you can do all-day sync, doesn't mean that the cloud's always going to have the most current activity data available. So we've worked with you on our WHO project as well, which is funded by NSF, where we're trying to study the difference between pushing behavioral feedback to somebody versus pushing a self-monitoring prompt. And we've used the Engage platform to be able to do that. So we're getting real-time steps over the last 2 hours off of the watch without having to sync all the way up to the cloud. And we can push that feedback to people in the moment at the time that they're randomly selected to get that notification. And likewise, we're able to push the self-monitoring prompt to them on the watch so that they can enter the information about how active they think they've been. So, you know, the more we move things to the user, the closer we bring the action and the processing to the user, the less likely we are to run into these different failure points of, you know, sync time or device, the phone not being on them at that place. So that's kind of the way we've approached it. And we would honestly love to move a lot of these interventions onto the watch. You know, I've talked to you a little bit about you and Haley, both about our AIM project and trying to move some of that to the watch. And it'd be great to chat more about that, because I think that the more we can do on the wrist, the easier it's going to be for people to be successful with their behavior change.
Yeah, David, we do have one question kind of in a similar vein. An attendee has asked us, David, for your 6-month data collection, can you talk more about how you're dealing with wear time if minute-to-minute HR data is missing due to low battery levels?
Yeah, so we're looking at the windowed heart rate data, and we do have some rules set up. The challenge for us hasn't been so much the low battery levels, because we're not running down the devices very often. The bigger challenge on our end is the potential that Fitbit's created for you merging data from the phone sensors when a person's not wearing the watch. So, you know, we had initially started out with a rule where we would say, you know, you could end up with 0 steps recorded and a heart rate. And we felt very confident that if you had 0 steps recorded, but you had a heart rate, you were just sitting down, and that's fine. And if you had 0 steps recorded, but no heart rate, that's pretty clear too. Well, there's 2 options. You're dead or you're not wearing the device, and we can rule one of those out with a phone call. But the third situation that came up that wasn't expected was we saw sometimes where we would have non-zero steps, but no heart rate. And that was confusing for a little bit until we learned that the Fitbit app is set up that if there's no data coming from the watch, they seem to pull some data from the phone sensors to try to get a better representation of your activity on the day. Now, it's a really nice feature from their standpoint. I think it helps fill in some of those gaps where information is missing. From our perspective, it was less helpful. We've now had to figure out a new way of handling data, and we've got a little more missing data than we wanted necessarily. But the battery running out has not been a big problem with the Fitbit devices. They're really good on power conservation, and it seems, you know, users are charging maybe once a week. I'd have to go back and check the exact data, but you also can monitor that in the field with the Fitbit interface, or Fitbase interface, sorry. So yeah, I hope that answers the question.
Yeah, that was the only question that came through. If the other participants, oh, he says thanks. If anyone else has questions for David, you can certainly send them to hello@Fitbase, and we'll pass them on and try to get an answer for you. But otherwise, I think we're at about time. So David, if you have anything else to say or share, or anything we didn't talk about, do you want to do that now?
Yeah, I just want to thank you, Haley, for organizing this, and Aaron for the conversation today. This has been fun. And thank our funders at National Heart, Lung, and Blood Institute and the National Science Foundation for paying the bills so that we have a chance to work together on these things.
Great. And Aaron, do you want to say anything before we jump on?
I think this was excellent. I really appreciate, you know, you hopping into our virtual booth here. And I hope that everybody got a chance to really see something very, I think, cutting edge and some really interesting work that it really exemplifies what is possible. Things that we're still even just kind of getting our head around in terms of what's possible. So thank you for showing us your work and for for being such a great partner with us on this. And I know that we're going to stick on. We're going to sort of end the virtual booth and say thank you to you, Dr. Conroy, and then we will stay on and have just sort of open booth hours as well to answer any other Fitbit or wearable device questions as well. But thank you again so much.
Yeah, thank you so much, David.
Thanks. Stay well, everyone.
Okay, you too. Bye-bye.
Bye-bye.